Have you ever wondered about the difference between a hydrogen bomb and an atomic bomb? These two types of bombs, both of immense destructive power, represent the pinnacle of human ingenuity and the depths of our destructive potential. The atomic bomb, composed of heavy elements like uranium or plutonium, was used historically in World War II, devastating the cities of Hiroshima and Nagasaki. On the other hand, the hydrogen bomb, also known as the H-bomb or thermonuclear bomb, operates on fusion and is considered the most powerful weapon on the planet. The detonation of this bomb creates a violent fusion process, occurring at extremely high temperatures and resulting in an explosion of unparalleled force. Both of these weapons have left indelible marks on our world and our history. But what exactly is the difference between these two devastating weapons? Let's explore. First, we'll delve into the science behind the atomic bomb. The atomic bomb is composed of heavy chemical elements such as uranium-235 or plutonium-239. Its operation hinges on the process of fission, which involves the splitting of the atomic nucleus. This splitting results in a massive release of energy, causing a devastating explosion. The world bore witness to the destructive power of the atomic bomb during World War II, when the cities of Hiroshima and Nagasaki were obliterated by bombs composed of uranium-235 and plutonium-239, respectively. The impact was staggering, reducing these vibrant cities to ruins in an instant. However, despite the immense power and destructive capability of the atomic bomb, it's not the most potent weapon in our world. That dubious honor belongs to another weapon, one that operates on a different atomic process and boasts an even higher destructive potential. That weapon is the hydrogen bomb. Now let's turn our attention to the hydrogen bomb, the most powerful weapon on the planet. Unlike the atomic bomb, which uses heavy elements like uranium or plutonium, the hydrogen bomb, as the name suggests, utilizes hydrogen, a light element. The hydrogen isotopes involved in this process are known as deuterium and tritium. Instead of fission or splitting of the atomic nucleus, this bomb operates on the principle of fusion, or the joining of atomic nuclei. This process occurs at incredibly high temperatures around 10 million degrees Celsius. When the hydrogen isotopes combine, they form a helium nucleus which has 4 times the atomic mass of hydrogen. This results in a much more violent explosion than fission, creating a force many thousands of times more destructive. One of the most notable examples of the hydrogen bomb's destructive power was demonstrated in the nuclear test codenamed Ivy Mike, conducted by the United States on November 1, 1952. The test took place in Enewetak Atoll, Marshall Islands, and the resulting explosion was so immense it created a crater about 2 kilometers in diameter. The destructive capacity of the hydrogen bomb is measured in megatons, with 1 megaton equivalent to 1 million tons of dynamite. To put that into perspective, the atomic bomb's destructive power is equivalent to a mere 1,000 tons of dynamite. The hydrogen bomb's destructive capacity is measured in megatons, making it significantly more destructive than the atomic bomb. Behind these weapons of mass destruction were teams of scientists working on what would be known as the Manhattan Project. This was a top-secret initiative during the 1940s, spearheaded by the United States, with the primary objective of developing the atomic bomb. Key figures in this groundbreaking project included Julius Robert Oppenheimer, Edward Teller, and Philip Morrison. Oppenheimer, a brilliant physicist, was the director of the Manhattan Project, and his leadership was instrumental in bringing the atomic bomb to fruition. Edward Teller, another participant in the project, is often hailed as the father of the hydrogen bomb. His work laid the foundation for the creation of this even more powerful weapon. Philip Morrison made significant contributions too, working on the development of nuclear reactors. But the legacy of these bombs extends beyond their creation. The detonation of these weapons had long-term effects on both the environment and populations. Take the Enewetak Atoll and the Bikini Atoll for instance. Both were used as nuclear test sites, and the massive explosions left these places uninhabitable for decades. In fact, it was only in the 1980s that the Enewetak Atoll was declared free of contamination. The Bikini Atoll, despite being a UNESCO World Heritage Site, remains uninhabitable to this day due to nuclear fallout. Both the hydrogen and atomic bombs have left indelible marks on our history and environment. Understanding them helps us comprehend the immense power and potential devastation of nuclear technology.